Hey everybody, it's Mr. Carr again. Today we're going to be covering 9.4 day 3, properties of chords. We focused on secants and tangents the last lesson. Today we're focusing on chords that are going to be inside of a circle. All right, so congruency and minor arcs. In the same circle or congruent circles, chords are congruent if and only if their corresponding, whoops, hold on. I thought I was doing something different. Okay. Intercepted arcs are congruent if and only if their corresponding chords are congruent. So what that means if I look at this diagram, since AB and CD are congruent to each other, their intercepted arcs here and here will also be congruent. So I'll put those right there. So since AB is congruent to CD, then arc AB is congruent to arc CD. The if and only if part of this statement means that it goes backwards. If I know that the two arcs like this are congruent, then I know that these chords are congruent. That's all. The only other thing then to mention is because it talks about or incongruent circles. So if I get something weird where I get, I don't have a lot of space here to work with, but yeah, I'll just draw it down here. Let's say that these two angles here or circles here, that is congruent to that radius. That means these two circles are the same. Well, if that's the case, then I can make a statement. If this is congruent to this, then I know that that arc and that arc are congruent. That's all. It's a little bit confusing, but it's just trying to make sure we understand. If I have two chords that are exactly the same length as each other, that are inside the same size circles, then we have congruent arcs as well. So in this scenario, in the diagram, circle A is congruent to circle D. And again, we're identifying that because of these congruent radii. BC is congruent to EF, that's given with these two. And EF is the measure of arc EF is 125 degrees. Find the measure of BC. It's the same thing. The measure of arc BC is 125 degrees as well. That's it. Okay. Some other ones though. Properties of chords and its diameter. If one chord is a perpendicular bisector of another chord, then the first chord, okay, sorry. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So what that means is if I look at this diagram, let's say that, so we're looking at SQ here. If that bisects TP and RP like that, so those are congruent and it's a right angle there, that means that SQ, my conclusion is that SQ is a diameter. The converse of this is also true. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So on this diagram, the way that looks is this. So yeah, I'm just gonna go ahead and erase this again. So if I know that for a fact that this is a diameter, so let's say it goes through point W here. Okay, so SQ is a diameter, then that, and it's perpendicular to SQ like this, then I know that this is bisected, and I also know that these are bisected. That's the idea of that one. Congruent chords in the same circle or in congruent circles. Two chords are congruent if and only if they are equidistant from the center. You remember when we talked about equidistant in our first lesson? That means they are the same distance. So in this diagram, okay, that chord is 12 and that chord is also 12. What that means is this and this are the same distance to each other. They're not radii. They're the distance between the center to the chord and the center to the chord. So these two pieces are the same. Okay, and so we establish that because segment AB, that chord, is equal to the segment CD. That's given right there. So that means I can say 7x minus 8 is equal to 3x. I'm going to subtract 3x over, and I'm going to add 8 to this side. So that's gone, that's gone. I get 4x equals 8. Divide by 4, and I get 2. Now the problem says to find EF. EF is that piece right there. So that means EF is equal to 3 times 2, so that EF is equal to 6. All right. Some other ones. Segments of chords theorem. This one's a little bit tricky for sure. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. All right. This diagram, before I get into the actual example, you can kind of can see it like this. This is for any two chords. So let's call it A, B, C, and D. So if I multiply like what's on the same chord, so A and C are on the same chord, B and D are also on the same chord. So in this scenario, A times C is equal to B times D. That's what we're trying to describe here. So that's what I can apply down here. When I want to find the lengths of ML and JK, well, I've got X and X plus 5 are on the same one. So that's going to be multiplied together there. I also, have X plus 3 and X plus 1. So those are going to multiply together. That's my setup. Now, when I multiply through, you got to be careful, just like we did before. This needs to be distributed, and then X needs to be distributed. So X times X plus 5 is going to be X squared plus 5X. And then here, I'm going to distribute that, so that X times X is X squared plus 1X plus 3X plus 3. Now, if I notice, if I subtract X squared to both sides, they actually go away. So instead, I'm going to have a 5X is equal to, we'll put these together. So that's 4X plus 3. And then I will subtract 4X over. And I get X equals 3. So the question actually asks us to find ML. So that is going to be the entire length there, ML, and JK. So that's the other entire length there. Okay, so that's what I'm going to do there. I'm just going to plug in my 3 now and find all those pieces. So I got 3 plus 3 is 6. 3 plus 1 is 4. That piece is 3. And then 3 plus 5 is 8. So what I have now is that ML is equal to the total length of 4 plus 6, which is 10. Okay. Again, that's 4 plus 6. So that gives me my 10 there. And then the other one's going to be 3 plus 8. So that gives me 11. So JK is equal to 11. All right. Handful of you trying out problems. These are, again, lots of different possibilities I'm throwing at you. It's going to take practice. So just make sure that you are practicing on the homework and seeing enough of these examples so that you understand what you're doing for quizzes and tests. All right. That's it for 9.4 day 2, or day 3 technically. If you have any questions, please feel free to reach out. Otherwise, that's it. Take care. Enjoy the rest of your day.